So whoever are not yet in the group, later on please contact Zuki. So Zuki, could you please help to add on the rest for those who are not yet in the group, because I'll do some communications through the group as well, announcements, sharing news, um, latest development in the field. So I normally share in the group, and then we can discuss accordingly, right?
Okay, Arthur.
All right, thank you, Zuki. So now let me share the slides. Okay, I'll share this slide on eLearn eventually, yeah, but don't worry about that. Don't worry about that yet. Let me approve few more joining now. Chat. Okay, all right. So just to confirm, if you can see the slides on the screen, you can reply in the chat box.
Yes, Doctor.
Okay, that's good. Thank you. All right, good. So, yep, welcome to ZAT386. So this is a course called Physics of Semiconductor Devices. So basically, in essence, you're going to learn about the physics of semiconductor, and then in the second part, you're going to learn about the semiconductor devices involved. Okay, today we're going to have a brief course introduction. I won't take long. So we're going to have some discussion as well along the way, especially on the timetable, your clashes between your classes and stuff, right? So if you look at this picture, for example, how do you explain this picture? Do you have any idea of how do you relate this picture to the course that we are going to learn? Anyone would like to give your opinion?
The wafer made of the silicon.
All right. Wafer made of silicon. Okay. And the silicon is made of what makes silicon? What makes silicon wafer? Anyone has an idea? How do you get the silicon wafers? Ah, right, sand. Okay. Sand, yes, good. Okay, some answered sand in the chat box, yes. Right, so you can see here at the back, if I can point, let me just, okay. So this is a silicon wafer with integrated circuits, right? With devices, with semiconductor devices already printed on the silicon wafer. So if you like, this is a finished wafer with devices on it, right? So that those chips could be your, chips in the phones or in the laptops or whatever. And this wafer is made of silicon wafer. So you can just imagine a silicon wafer as something like this with the same shape, but with a blanket appearance. There's nothing printed on a silicon wafer. By the way, have you seen any silicon wafer so far in the lab or in the previous courses? Have you seen how it looks like, the silicon wafer? Atau pernah tengok silicon wafer in the lab at all? In our lab or in other labs? No, not in real life. Okay, right. Not in real life. Not yet. Anyone has? Belum lagi. Okay, so we're gonna go through that later on. So not yet. Okay, right. Thank you. And if you say, if you dice or if you cut the devices on the silicon, the finished silicon wafer here, you're going to get perhaps something like that, the chip. Okay. And this chip or the silicon is originally from sand, right? So you can just imagine this sand. Okay. So you know what makes sand, right? What makes sand? Silicon dioxide. Okay. Sand is silicon dioxide, SiO2. So you can then process, we're going to learn later on, you can then process the silicon dioxide by removing the oxygen, then purify the silicon to be able to get to the right level that can make semiconductor devices work. So it depends on whether you're going to fabricate integrated circuits or solar cells or power devices or whatever, some other devices. So each device requires different level of purity. Okay, so we're going to explore some of the details in this course. So in essence, ZAT386 is going to teach you about the physics of semiconductor. And then in the second part, you're going to learn about the devices or the semiconductor devices which operate based on the underlying physics. Okay, so you're going to learn two parts: the physics of the materials, of the semiconductor materials, and then we're going to use the physics, the theories, the background, the operation principle in the devices. Okay, so there'll be two parts of this course. So let me just brief you the outcome expected, the learning outcome expected from this course. So basically, there are three outcomes expected from this course as listed as CO1, CO2, CO3. Course outcome number 1, you should be able to explain theories, characteristics of material, and operation of semiconductor devices by the end of this course. So that course outcome is related to knowledge. As far as the program outcome is concerned, we call that PO1 or related to knowledge. The second course outcome, CO2, you should be able to analyze problems involved in semiconductor devices by the end of this course. Okay, so after learning all the principles at the material level and at the device level, you should be able to analyze the operation, the issues, the problems, the calculations involved in the semiconductor devices. And that is related to PO3 or related to more towards thinking and scientific skills because it involves a lot of analysis. And then the third one, course outcome number 3, you should be able to present operation of semiconductor devices clearly and with confidence. And this is related to PO number 4, which is related to communication skills. So I'm going to brief you later on in the second part of this course. You're going to be required to present semiconductor devices in groups. Okay, so you're going to be grouped in 4 or 5, perhaps, depending on the total number that we have. And each group is required to present the operation, the basics, the related industry, which is related to your semiconductor device. Okay, so all together there are 3 learning outcomes expected from this course. Right, so before we move on, let's just discuss briefly on what you know so far about this question. And the question is, what is a semiconductor? Anyone? You can unmute yourself. Don't be shy. Normally in my class, I like to discuss a lot with students. You can just unmute yourself. You can write down in the chat box. Either one is fine. So what is a semiconductor that you know so far? Okay, we got the first one now. Fatahul, semiconductor is a material with a band gap between insulator and conductor. All right, that's one. Any other? What is a semiconductor? Why do you call it semiconductor? The first one is in terms of its band gap. So that means the semiconductor has a band gap in between conductor and insulator. Right, second one, anyone? Let me go through the names, yeah. So this is suka panggil nama, so that I can remember eventually. Righty, okay. Okay, we got the second one, Zuki. Conduct current when the photon energy same as or higher than band gap energy. Okay, as far as the photon is concerned, if you have incoming photons, for example, incident light, it can conduct current when the photon hitting the semiconductor is more than or equal to the band gap energy. We want to learn about the concept of band gap as well. Right, good, thank you. Next, anyone else? Vishalini. Vishalini, can you share what do you know so far about semiconductor? You can say anything that you know, that's fine. Because that's what we're going to learn after all. Any idea, Vishalini? You can unmute yourself. So while waiting for Shalini, let's go for Mariam. Siti Mariam, can you share what do you know about semiconductor so far? Mariam, boleh share? Siti Mariam. Malu ke semua? Jangan malu It's okay, you can just unmute yourself. Shalini dah ada jawapan, Shalini?
Doping, doctor.
Doping, okay, interesting. Doping, it has something to do with doping. Okay, so we're going to learn what is doping later on. Okay, thank you very much. Siti Mariam ada anything? You can share some keywords perhaps, just like Shalini is now. Mariam, Kuatin, would you like to share anything that you know so far about semiconductor?
Hello, doctor. Can you hear me?
Yes, I can.
Okay. What I understand about semiconductor is, it's a material that can conduct electricity between conductor and non-conductor, which is insulator.
Okay.
And there is two types of semiconductor, which is intrinsic and extrinsic.
Okay.
For intrinsic, it is made up of single element, such as
Okay.
silicon.
All right. Okay.
Extrinsic, there is two types, which is N type and P type.
Okay.
For N type is pentavalent impurity. For P type is trivalent impurity.
Okay, brilliant. Thank you very much.
Okay.
Okay, thanks. Okay, good. So, Quatin said, in terms of conductivity, it is between conductor and insulator. And they are intrinsic, they are extrinsic. Intrinsic is pure, there is no doping. To relate to Shalini mentioned just now, extrinsic can be P-type, it can be N-type. So if you want to work on P-type semiconductor, P-type silicon, for example, because you're going to use a lot of silicon as the reference to learn about semiconductor. So if you wanna do P-type, or if you wanna have P-type silicon, you have to dope with group number 13 impurities like boron, aluminum, gallium. On the other hand, if you wanna get N-type silicon, for example, N-type semiconductor, you have to dope the silicon with group 15, right? Or group 5 last time we said. Phosphorus, arsenic, and in order to produce in the lattice. Okay, good. So let's move on. Are you using semiconductors in your real life? Do you use any semiconductors in your life? Anyone? Yang belum jawab lagi. Ada tak? Do you have any semiconductors with you now? Haziq, do you have any semiconductors with you now?
Yes, doctor.
Okay, can you share a bit? Kat mana tu?
Handphone.
Handphone. Okay, can you be more specific in the handphone? Then where do you find your semiconductors? Generally? your handphone is a semiconductor or it sits in your handphone?
In the chip of the handphone, inside the handphone.
In the chip, right? In the chip inside the handphone, right? Thank you. Others, ada lagi semiconductor? Do you use semiconductors in your life now? Najia? Najia, do you use any semiconductors? Oh, ada dua Najia ke ni? Najia Nasir dengan Najia saya punya FYP. Najia FYP saya ada. Najia Ramli. Najia, do you use any semiconductors now? Would you like to share whereabouts?
In our laptop.
Dalam laptop kan? Inside the laptop, right? The chips and everything,
Yes.
right? Okay, thank you very much. So we have pretty much, we are using a lot of semiconductors nowadays. Laptops, phones, gadgets. So if you want to move into the future with smarter, smart home, smart this, smart that, smart whatever, AI, all semiconductors. Okay, that's why you can see lately when we had COVID and we still have COVID. You can read the news on the global chip shortage, right? And that doesn't affect only the chip industry, but also affect some other industry. For example, if you talk about automotive, kereta lambat production because of the chips. Because kereta sekarang banyak electronics and you can do the sensing, this, that, right? All chips, all semiconductors. So bila you ada shortage in semiconductor industry, and then it affects some other industries as well, right? So that's how powerful semiconductors are. For example, okay, if you look at A8 chip on this slide in iPhone, A8 chip dah lama ni, sekarang dah 12, 13 with line width critical dimension of 15 nanometer fabricated by extreme UV lithography, extreme ultraviolet lithography. So you can see down here in the picture. Later on, you can play this YouTube video and see for yourself. You can see if you zoom into your chip, okay, if you zoom into your chip, you can see that the architecture, the building block, macam building bangunan tepi jalan, but the architecture, the building block of your chip is down to somewhere between 15 nanometer. And this is only A8, right? 15 nanometer is like way, way smaller than your hair, right? Our hair thickness is only about 80 micron or so, and that's like 10 to the power minus 6. And this is 10 to the power minus 9, okay, and 15 nanometer. And now the advancement in the industry already brings the chip fabrication, the chip dimension down to about 5 nanometer, 3 nanometer. And the moment it goes down, it reduces in terms of its dimension, it will get more and more powerful. It can do more things, right? It can perform at higher capacity, and then the speed is higher, can get higher gigahertz, and then the power consumption will be lower. It can get more powerful functions. Okay, you can watch later on. So this is the building block that you have in your chips. Kalau you zoom in, nanti you can see, you can watch on this YouTube. If you zoom in from the chip yang kita tengok on the first few pages tadi, for example, this one, if you zoom into this, you're going to see lines and lines and lines. The moment you go down to the smallest unit that you can see, it is somewhere within 5, 10, 15 nanometer, depending on the technology. Okay. And this is made of semiconductor. For example, another one, if you look at Huawei Kirin 990 5G chips, so it uses CD. CD, for your information, is the critical dimension. If you go back to this, it belongs to the line width, the dimension, the width of the line, okay, that governs the operation of your transistor. Chip is transistor, so kita pakai chip for whatever, so it's actually a transistor as a device. But if you look at the dimension, so it is as small as 15 in this case, right? 15 nanometer. So that is the CD. Critical dimension is actually the line width. So kalau you draw, for example, if I can sketch here the cross section of your MOSFET, for example, you're going to learn this one. So the gate here will be around that. 10 nanometer, 15 nanometer or so. Okay, so that is the critical dimension of the line width. So to be able to fabricate this chip, for example, you need to use a technology that's called extreme UV lithography, EUV, extreme UV lithography. The machine that you're seeing here on the slide in the yellow room. We're going to learn this one later on in 487 if you're taking semiconductor fabrication. The illumination wavelength of this system, the EUV system, is 10 to 14 nanometer. To be precise, 13.5 nanometer, to be able to print down to 753 nanometer. Okay, so if you have like a chip with CD of 7 nanometer, so it normally consists of 10.3 billion transistors per 200 mm squared area, right? Mass production already started in 2020 for Kirin 90. Now you can see more and more advanced chips being produced by a semiconductor giant like TSMC. You can read on TSMC, Taiwan Semiconductor Manufacturing Corporation. So they are now the king of wafer fabrication process in order to fabricate smallest and smallest and smallest chips. Right, TSMC starts 19.5 billion 3 nanometer fab back in 2019. So it's going to begin its production in 2023. So sekarang dah 2022. So next year, it is expected for them to start the mass production of 3 nanometer chips, okay, by TSMC. So in this course, so as I said, now you're going to learn about the physics in the first part and then the device in the second part. So the first 7 weeks will be taught by myself. Okay, I put here MZP. I'm going to teach you the physics, the basics, the fundamentals of material, how semiconductor works, the concept of band gap, Fermi energy, P-type, N-type, intrinsic, extrinsic, carrier transport, PN junction, electric field, all those stuff, right? And in the second half of the course, the course is going to be taught by Dr. Marzani. Okay, so MMR here, Muhammad Marzani, Muhammad Rashid. So he's going to take the devices part. Okay, so you're going to learn all the devices with him, right? After learning all the basics of physics of the semiconductor with me in the first 7 weeks. So basically, this is the course outline. So we're going to start with introduction to semiconductor materials, the concept of crystal structure, energy band. Some you've learned in 307, solid state physics, right? Density of states, property of occupation, how do we calculate density of free electrons and holes. And then week number 3, you're going to learn about intrinsic, extrinsic concepts, just like what was mentioned by Quatins now, the P-type, N-type doping mentioned by Shalini, right? A carrier transport phenomena. How do the carriers move? How do the electrons and holes move in equilibrium condition? And then in electric field condition, how do they drift? How do they diffuse? Generation and recombination processes upon excitation by injected current, by light, as mentioned by Zuki's now, photons. So in week 5, you're going to learn about excess carriers in semiconductors. So the moment you have got your carriers stabilized in thermal equilibrium condition, how do we then generate new carriers? So we call these new carriers as excess carriers. Maksudnya semiconductor tu dah berada dalam keadaan equilibrium. So the moment you say you let the semiconductor be in equilibrium condition, and then you induce formation of new carriers, generation of new carriers, and these carriers are called excess carriers. And then the moment you have your excess carriers, you want to know how long can they survive, and that's called minority carrier lifetime. How long do they survive before they recombine, right? So you're going to learn the concept of generation and recombination as well later on. And then diffusion length, how far do they diffuse? How far do they travel before they recombine and gone? Annihilated, right? Continuity equation. And then week 6, we're going to start learning about the concept of PN junction, right? What is PN junction? How do we form PN junction? What happens to the PN junction under thermal equilibrium? So essentially, you're going to bring P-type material, P-type semiconductor, and N-type semiconductor together as one piece of a semiconductor block. So you're going to learn on what happens at the interface the moment you join P-type and N-type side by side, right? So you're going to reach thermal equilibrium upon joining the p-type and n-type. And then what happens then when you connect the p-n junction under forward bias condition? That means you sweep the voltage into the positive region and then see what happens to the carrier's movement and all the stuff at the p-n junction. And then on the other hand, you're going to learn about what happens when you reverse bias the junction as well, right? And then diode equation, what are the important properties of diode equation? And then in week 7, we're going to finish off with p-n junction under illumination. What happens when you join the p-n junction, you leave the p-n junction under thermal equilibrium, then you start illuminating the p-n junction under light with photons of different energy levels, right? And then IV characteristics, p-n junction breakdown, p-n junction diode, and examples. And then week 8 is the mid-sem break. And then in the second part, this will be continued by Dr. Marzani. You're going to learn about metal semiconductor junction. So junction can be formed by bringing together the same material of different polarity, p-type silicon, for example, and n-type silicon. On the other hand, you can also create a junction by bringing together a metal, say silver or aluminum or copper or gold, to a semiconductor. And that will form metal semiconductor junction. It is also a junction, but it's not a p-n junction, but it's called MS junction, metal semiconductor junction. You can also form semiconductor heterojunctions. So this means you can form a junction by bringing together semiconductor material with different band gap or completely different material. For example, if you join zinc oxide and amorphous silicon, that is called heterojunction. If you join crystalline silicon with amorphous silicon, they are both silicon, but then one is crystalline with different band gap, 1.1, and amorphous silicon, 1.8. So that is also considered heterojunction, right? Or you can bring materials with different, completely two different materials altogether, like copper, indium, gallium selenide with cadmium sulfide, for example. So that is considered as semiconductor heterojunction as well. So week 10, you're going to learn about fundamental of MOSFET, metal oxide semiconductor field effect transistor. So this is a transistor driven by FET, by field effect. So you're going to see the architecture later on. And then week 11, you're going to look at metal semiconductor field effect transistor, additional concept. This is more advanced concept of MOSFET. And then you're going to learn about bipolar junction transistor, BJT, JFET, junction field effect transistor. And then you're going to learn about photodetectors, LEDs, solar cells, power devices. And in this part, in the second half of the course, this is where you're going to learn you're going to do your group presentation, okay? So let's look at the class timetable and let's discuss the clashes as well. Right, so we're going to have altogether 14 weeks, 7 weeks by myself, and then 7 weeks taught by Dr. Marzani. And then if you look at the original schedule, this is how it looks like. So we are going to have a class on Monday 10 to 11, Tuesday 4 to 5, Wednesday 9 to 10, and Thursday 10 to 11, right? So the classes will be conducted on WebEx by myself and Dr. Marzani. So now let's just go through the clashes for every single day. Right, so let's discuss on Monday first. Monday, right? So quite a number of students have clashes,
Doctor,
right?
Monday's
Yeah.
clash. Yes, Monday
Okay.
clash. Can
Okay,
we
Monday clash.
to Monday 8 to 9?
Monday 8 to 9. Monday 8 to 9 not possible. Is it okay in the afternoon? So hold on, let me see
What
my
time,
calendar as
Doctor?
well. Hold on. What if 2:30 in the afternoon?
Doctor, that time English class.
Boleh ke? Oh tak boleh. Ada yang tak boleh. Okay, siapa yang tak boleh just highlight What if Monday? Sorry, tak boleh.
Yeah,
Monday.
I have English class that time.
Okay then. Monday 3:30 possible?
My class until 4 o'clock, Doctor.
Okay, so Monday's gone. Tuesday we're gonna have. Okay, what if Tuesday We
Yeah,
have a
2 hour class.
2 hour class. Yes.
Yeah. I'm okay with that.
Anyone okay say
The
ada
I
yang tak boleh ke?
have minor on Tuesday from 3 to 5.
Okay
Minor
then.
class.
Then what about Monday, Tuesday morning?
Yeah. Tuesday
What time?
morning, I got nothing.
Okay, say Tuesday 10 to 11, 10 to 12. If you want to combine,
I get classes
I'm free.
on Tuesday 10 to 11.
Yeah,
10
Doctor,
to
how about
11.
11 to 12? 11 to 1?
Yeah, I'm okay. 11 to 1. Anyone has clashes? 11 to 1. Tuesday.
I'm free.
I have class.
Okay, siapa ada class tolong beritahu Let me just note down first. Tuesday 11 to 1. Okay, anyone not okay? Tuesday 11 to 1.
I not okay, sir.
Oh, tak okay. Okay, you ada class.
Ada kelas doktor. Pukul 11 sampai pukul 12. Ada kelas
Okay.
language.
Alright, so not possible then. So let me see. If possible, let's have 2 hour, two set of 2 hours class. How about Wednesday afternoon? Semua free ke? Wednesday afternoon, say 2:30, 4:30. Is it possible? Or 3 to 5?
I got
Yes,
classes
I'm free.
on 11
I'm
to
free,
1.
Doctor.
You have a class 11 to 1.
Yeah.
Adli,
Yeah.
okay. So how about 3 to 5? Is everyone
Yes,
okay?
in the evening, I'm free.
3 to 5 on Wednesday, I got class minor.
Aduh, semua ada kelas.
Thursday, I only have one classes, doctor.
Nanti yang lain pula clash. How about Thursday afternoon? Thursday afternoon, everyone free, say 3 to 5.
Got minor, doctor. 3 to 5.
Tak boleh juga 3 to 5. Thursday morning 10 to 12.
Yes, I'm free that time.
Anyone okay? Everyone okay? Thursday 10. Sorry?
Class, doctor.
Kelas juga? Semua kelas ni macam mana ni?
How about 11 to 12, 11 to 1, Doctor, on Thursday?
Thursday 11 to 1. Yeah, I'm okay. Yes.
Yes, I'm okay with that. So,
All right. Who's not okay? 11 to 1 Thursday.
I have class 11 to 12. Doctor, I also have a class.
Oh. Full ni dah tak boleh dah ni.
Seems that we only can make 8 to 9, Doctor.
8 to 9 I kena travel. I on the way selalunya. I travel pergi sana. Tak sempat. How about Friday? Friday morning? Friday 10 to 12.
yeah, free.
Semua okay? Okay. Anyone not okay? Friday 10
I
to
have
12.
minor.
Doctor, maybe
11
ask
to 12.
Friday morning like 9 to 11 because that time is English. Is it everyone finish the English?
Yeah, I'm okay at 9 to 11. Friday 9 to 11. Is it okay? Okay, no clashes. 9 to 11 Friday. Sounds good. Boleh Right, Friday 9 to 11 done. Friday 9 to 11 a.m. Ada ke? Siapa clash?
Sorry, I got class.
Oh, you got class?
Yeah.
What time?
8 to 9. Sorry, 8 to 10.
Okay, 8 to 10. How about 10 to 12? Everyone else okay? Friday 10 to 12.
I have class 11 to 12.
Tak ada kelas lah sekarang ni. Semua dah full.
I cannot already no schedule.
Yeah, no other time then.
How about split it with 1 to 1 hour period only.
Sorry?
On Friday from 10 to 11, so that other person who have classes on the 11 to 12 can
Yeah,
can
okay.
attend.
Friday 10 to 11, okay?
10 to Friday 10 to 11, doctor.
Yes, okay?
Oh, I have class on that time.
Ah, see? All right. Friday afternoon, 3 to 5.
3 to 5. Friday got class 3 to 4.
3 to 4. So tak boleh lah. Semua dah penuh ni macam mana?
How about we don't reschedule the subject? We try to reschedule the other.
Yeah, if I'm okay with that. I'm trying to accommodate if possible. If not, then we have to leave the schedule already.
I think also can.
Can. So that means we stick to the current schedule?
Yes, I think for this week we stick to the current schedule. We try to reschedule the other subject first.
Okay. Alright then. Okay, you try to reschedule other subject first. It looks like sebab kalau ada common time, then it's okay for us to reschedule. But it looks like ada for every slot ada yang tak boleh kan. So it looks like you try to reschedule some other subject. Okay.
Okay, doctor.
Okay, then let me know. Maybe we can discuss again next Monday and see what's the progress. Okay, nanti remind saya next week punya class, see whether you can make it or not. Alright. So let's move on. Okay, hold on, let me move this a bit. Well, this is actually the course assessment. Okay, this course will be on 100% coursework. Okay, it'll be 100% coursework. So you can still see the screen, right?
Yes.
Okay, good. So it's gonna be on 100% coursework mode, and then that you're gonna have 2 tests altogether. One in the first half of the course in the first 7 weeks, and another one will be in the second half. So first half one, second half one. So you're gonna have 2 tests, 20% each, right? So that will bring you to 40% of coursework mark for the test. And then for assignment, you're gonna have 1 assignment in the first half of the semester. So that will contribute to 30% of your coursework mark. And then in the second half, you're gonna have your group presentation, and that will contribute to 30% of your coursework mark. Okay. So 2 tests, 1 assignment, 1 presentation. So there is no final exam for this course. So for the teaching plan, let me show you briefly the teaching plan. Hold on, yeah. Okay, let me share the teaching plan. Right, can you see the PDF on the screen? Can you see the PDF? Okay, good. Thank you.
Doctor can see.
So this is basically how the course is going to be taught in terms of the outline. So there are 2 lecturers teaching this course. And then if you want to have any question, well, I'm not that rigid in terms of your question, or you want to see me, you can just let me know. You can meet me face to face. We can arrange that, or you can always discuss on WhatsApp if you want to. Okay. So I schedule here Friday 10 to 11 for appointment if you want to meet me. But on other times, if you want to meet me, you can also let me know. Okay. I'll be most of the time at INO, but I'll be in the school every now and then, right? So as of now, we're gonna use the current timetable, and let's see how can we change that next week if we can do that. So I've gone through the course outcome just now. So the course assessment will be based on 100% coursework, 100% coursework. So 30% from assignment, 40% from 2 tests, and then 30% from your group presentation. So this is briefly the course outline, and then the teaching weeks and everything. So the assignment will need to be handed in around week 6. Okay, so I'm going to give you your assignment around week 4. So normally it's going to take about 2 weeks. So we're going to have your test 1 in week 7. Okay, so that will cover from day 1 of the course until probably until end of week 6. Okay, until diode equation. So let's see how the progress looks like as we go. So this is a bit flexible in that sense, but generally if we can finish diode equation by week 6, so we're going to have week test 1 covering from day 1 item until diode equation. And then your SEM break in week 8, and then you're going to come back in week 9. Then we're going to continue, and then you're going to have your presentation somewhere in week 14. Okay, so I'm going to give you, Dr. Marzani is going to give you your presentation assignment normally 2 to 3 weeks before. So that will probably be around week 11 or so, right? And the presentation has to be done in week 14. And then week 15 will be the test 2 week, right? So let's see how the progress, and I'm going to discuss with Dr. Marzani on this. But roughly, that's how it looks like, right? So test 2 will be revolving around devices, okay? So that is all for the teaching outcome, teaching outline. Let me just go back to the slides and finish off. Right, just to confirm if you can see the screen. Can see the slides on the screen?
Yeah, Doctor.
Okay.
Let's see.
Right,
Yes,
so
Doctor.
right, the main reference for this course will be this book, right? Semiconductor Physics and Devices by Donald A. Neiman. You can find this online as well. There's PDF for that, right? You can search online. So textbook, you can also use SMZ or BG Straitman for the alternative, okay? But all in all, I don't depend on just a textbook. So I have my sources from some other references as well. You can see along when we go. I'm going to use some websites for our reference along the way. So attendance, make sure you attend the class. Well, let me create one Excel for you to fill in later on. But as of now, I can track your attendance by your login on WebEx. That can be extracted. So not everything is on the lecture notes, right? So I teach something else as well in the class that is outside lecture notes. So please don't miss your classes. So late submission of assignment will not be marked and entertained. So make sure you submit on time. Plagiarism, you know about this already. You're a third year student. So, okay. There's no exam for this course. Right. Why this course is important? I would like to finish off with this. Why join this course? Anyone would like to share? From medical and from pure physics? Because applied, it's compulsory for you, right? At least in that sense. For the one from pure or medical, would you like to share why would you like to join this course? Before we continue. Anyone? You can unmute yourself. Siapa tadi from pure and medical? Siap je ni? How would you like to join this course? What do you want to learn? Yes. Siapa ni?
Mariam.
Mariam, yes. Go ahead, Mariam.
So why I joined this course because I thought this course might be useful for me to join in industry in the future.
Okay, all right. Thank you, Mariam. You're from pure or medical?
Medical.
Medical, right. Thank you, Mariam. Okay, any other? One more? Maybe from pure, anyone? What do you want to learn from this course? Any second volunteer before I finish off? Tak ada. So let me just go straight, right? If there's no volunteer to share why this course is important. Okay, I'd like to make it clear why this course is important. So you have been learning all the physics. And then I believe you learned a little bit on semiconductors as well in the previous courses, here and there scattered. But this course is going to connect you to the outside world, right? So you are in the room now, in the room on the slides, and then I'll be trying to open the door for you to see what is on the outside world, right? So let's see. So why this course is important? You're going to learn about important physics concept in semiconductor devices. Okay, if you don't learn the physics concept in semiconductor devices, you don't know what's going on inside. So if you learn on the electrical electronics level, probably you learn a little bit of basics of the physics, but then you don't really go down to the fundamentals. If you don't go down to the fundamentals, if you work in semiconductor industry later on, you don't know what's going on at the fundamental level, right? I can guarantee you on that. It's a vital foundation to enter industry as a physicist, scientist, engineer in IC, LED, laser, solar industry, and whatnot, right? You can see so many new companies coming into Malaysia, especially Penang, Kuala Tech Park. This year, last year alone, a couple of big multinationals company came in, right? Important fundamentals for research if you want to do your postgraduate or in fact in your FYP as well, right? So if you work on semiconductor materials and devices, you will eventually appreciate semiconductor devices in real life. Okay, you know how it works, you know what are the issues involved, how easy or how difficult to fabricate one. So you will eventually appreciate every semiconductor device in real life. So if you talk about semiconductor, you are talking about electronic and electrical electronic industry overall, right? Globally and also in Malaysia. So for your information, EE industry consists of many, including semiconductor sectors, right? So semiconductor is one of the main contributors or main players or main domains, if you like, in EE industry in Malaysia. So for your information, EE industry exports is about 40% out of the whole Malaysia's export 2019 onwards, right? So it's getting bigger and bigger with more industry coming in. So in EE industry, there are 5 subsectors. So bila nanti you belajar all the semiconductor devices, material devices, and you want to go for your internship, for example, next year, right? So you have all these 5 subsectors if you want to join EE industry, E&E industry, right? So the first subsector is called semiconductor, and that covers IC design, fabrication, assembly, test, generally. Another subsector is called optoelectronic and LED. If you see Osram, Lumileds, and some other companies, they are in this domain, in this subsector, optoelectronic and LEDs. The third subsector is called solar photovoltaic, right? So you can see companies like First Solar, JA Solar, Jinko, Q-Cells, Longi, Trina, many more, right? They are manufacturing and some R&D as well. Some are doing R&D on PV cells, panel, balance of systems. The fourth subsector is called system electronics, where it covers product and equipment makers, OBM, contract manufacturers, PCB, and many more. And then the last one is manufacturing related services like plastic injection, metal stamping, automation system, so on and so forth. If you look at the whole E&E value chain, this is how it looks like. The below one, E&E value chain, right? So normally if you talk about the value chain, the whole spectrum from the start, so it normally start with IC design, right? If you want to fabricate transistors, for example, you need to start with IC design. So then the design has to be fabricated. So this is the core of this subject. And if you take ZAT387 next semester, fabrication processes, so you're going to learn a lot more on this, right? And then assembly and test followed by PCB, and then it goes into the product and, goes into your TVs, laptops, whatever, right? Other devices. So that's how the E&E value chain looks like. So if you want to work in E&E industry, there are altogether 5 5 subsectors. So in our neighborhood, you can see we have Celterra, Infineon, Osram, Vitrox, First Solar, Jinko, Western Digital, Optic Browsers, and many more. And Intel just announced that they're going to invest $7.1 billion in Malaysia for the span of 10 years, starting this year. And then ATNS just opened their manufacturing in Kulim High Tech Park. It's going to start the production, I think, this year or next year, latest. And then we have Ryzen coming in, Ryzen Solar, working on silicon solar cells in Kulim High Tech Park as well, 42.2 billion ringgit Malaysia investment. So you can see strong presence of many companies in Malaysia. You can see Western D, Jabil, many more. You can see in Penang, you can see, and basically they are coming from various companies around the world. And then if you talk about solar cell, for example, Malaysia is the world's third largest manufacturer in 2018 and onwards. We have so many companies in Malaysia. And then I'm almost done. So among my teaching philosophies that I would like to share with you in my class, I believe there are no stupid questions from students, right? So you can ask me literally anything about the subject. So I believe engagement with students enhances learning experience. So that's why I ask you to talk, I ask you to engage so that we can discuss more, right? I believe understanding beats memorization. You can memorize, but then it won't last long. If you understand the content, it will last longer, right? Then you memorize. I believe students' holistic development is the ultimate goal of education. So it's not only on scoring CGPA, it goes beyond that to be able to be a successful student and citizen in the future. So let's make this class a two-way street. We're going to have discussion every now and then, questions. We're going to work together on the screen, right? So if you want to come and see me for discussion, let me know. We can also discuss. And yeah, that's all for this class. Is it okay so far? Can you follow? At least for the course introduction. Is it okay? Do you have any questions so far?
No, doctor. So far, okay.
So far, okay. All right. So if there is no question, then okay, I'll upload the recording on eLearn later on, and then also the slides. Okay, I'll upload accordingly. And then I'll see you again tomorrow 4 to 5. Yeah. Okay then. If there's no other question, I'll see you again tomorrow. Bye bye. Take care. Assalamualaikum.
Bye-bye, doctor.